Everyone, it is Miss Karen. You have no idea how hard it is to find a book that has something about the letter V in it. There are a couple cute little, I'd call like primer books on volcanoes, but none that I could find, and of course the library's closed. We got lucky. I dug in my daughter's collection and I found this DK Wonder book on volcanoes. It also talks about a few other just like earthly phenomenons that we have. So we're just going to take a few minutes because we're working on the letter V, and I did a little like home volcano explosion. You got to forgive me. The wind caught my little phone and tipped it over, but wasn't that bad. We got it set up again really quick. It's really cool. It's something, you know, your parents can do for you in the backyard. Just don't make a volcano on anything that is green. So don't do it on the grass because the vinegar will kill the lawn area. So do it like out on the concrete. So anyway, this is a book on volcanoes. And volcano starts with the letter V. And so let's just take a few minutes and take a look at this. I mean, I dug and dug for this book. So let's learn a little bit about volcanoes. We do have some pretty close to us here. Now close, I don't mean like Tahoe is not a basin of water that was formed by a volcanic crater. No. It does have some earthquake faults in it, but Tahoe is not a volcano. But up north, in Northern California, we have Mount Lassen. And a little further north, we have Mount St. Helens. Up in, I think, Washington, that in the 1980s, yeah, it made a big, and then we have like Mount Vesuvio, I think, over in Italy, and a couple others in the Italy provinces on the other side of the world that seem like they're always erupting. Kilauea in Hawaii, one of our states, is an active volcano. Okay, so I mean, some of these stuff, I mean, they look really pretty. But if you jumped into a volcano, there'd be nothing left. It's hot like no other hot you can imagine. So I'm just going to kind of read a little bit here because this kind of breaks down a little bit of the volcano. Okay, so on the Earth, what we have down here, what we walk on, and like that first, 100, 200 feet, depending upon where you are, that's called our Earth's crust. So that's kind of like where, we dig in to make our train tunnels and our foundations for our houses, and we sink really deep foundations or piers to support things like the Golden Gate Bridge. Underneath that, we have some rocks and dirt. We get some more sedimentary rocks, and then we get down a few miles. Okay, the Earth starts becoming just like this liquid magma. And it just kind of floats all down there around the Earth. Okay, so what happens when we get a volcano is sometimes we have a little weak spot in the Earth. So instead of being nice and flat like this, all of a sudden, maybe there was a little earthquake, like we had one in Tonopah a week ago, 2 weeks ago, and my water filter to my refrigerator popped and leaked in my whole kitchen, so I've been dealing with a big mess. But a little earthquake might shift some of this crust and sedimentary rock so it's not all nice and tight. You can tell, see, I've been painting. And all of a sudden now you get like a bubble and there a gap. And so the lava starts to kind of come up underneath, and eventually you start to get a mound that comes up. Okay, down around Mammoth. Now Mammoth is not very far from us. It's about an hour and a half, about 90 miles, maybe 100, depending upon where you are in relation to Carson City or South Douglas County. Mammoth has active dome building, okay? And there's 2 volcanoes dormant, which means sleeping. They're sleeping volcanoes. Right there by Mono Lake. One is Pahoa, out in the middle of Mono Lake. It actually has fumaroles, which are like vent holes that steam comes up out of. And the other is Panem Crater, which is, I forget, I want to say it's about 1,000 years old. Not very. and it's got some really cool pumice plug in it. So anyway, you get this kind of break, and you get this dome building going on. Okay, so we got our break. Okay, and we got this magma down here. So something happened, and this nice layer of earth down here, it got disrupted. And now, this nice orangey magma stuff is starting to push up. Okay, and it's making this dome here. So like a mountain, okay? They call them a dome when we're talking about volcanoes, but like a mountain, okay? Well, at some point, as you push something up, like when you blow up a balloon, you know, and first it starts out really small, and then your balloon stretches and stretches and stretches, or maybe you're filling up a water balloon. That balloon is only going to stretch so far with water or air, and it's going to go pop. Same thing's going to happen with the Earth's crust. This magma pushing it up underneath and making these domes is going to get really thin up here at the top. And eventually, with this pressure building up, so like imagine you're shaking up a soda can, okay? And I don't know, I bet somebody has noticed, you know, mom or dad, you know, dropped a soda can out of the fridge or something and opened it, and it went because it had all that pressure. That's what happens with a volcano. So it's like a soda can that's been shook up, that's building pressure up under here. And at some point, it can't take it anymore, and it blows up. It's ready to blow. The force of an exploding volcano can throw lava. Okay, so in the earth, okay, when it's down here, it's called magma. Okay, it's literally molten or melted earth. But when it blows up and it comes out of its hole, now it's called lava. So if you want to see some lava, go to Hawaii and go to Kilauea. You will see lava. Okay, so it can throw lava more than 2,000 feet into the air. Okay, that's like a half a mile. Okay, so if you guys are standing in the Carson Valley in Minden or in the Eagle Valley in Carson areas, and you're looking up at the top of the mountains, okay? So Carson and Minden, there were about 4,800 feet there in elevation above the sea. Top of those mountains are about 9,000 feet, okay? Most of them, you know, kind of just, I mean, we have some peaks up there that are like, you know, 10, 11,000 feet, you know, if you look really high, but most of it's right around 8,000, 9,000 feet. Okay, so imagine like in the middle of the Carson Valley, you know, like where the river is, okay, where you got to cross the river, and all of a sudden right there, it just decided to go boom. Maybe this was just like a little earthquake, a little volcano. Halfway up to the top of those mountains in the Carson Valley would be chunks of lava getting thrown in the air, okay? Now, things can go even higher because you've got all this dirt that's up here. So like in the case of Mount St. Helens, and maybe somebody can Google for you, like the Mount St. Helens eruption, it had a pyroclastic ash, which is like really hot dirt that was like pretty much disintegrated into ash because it got so superheated and with the water in there and everything. It went up for miles. So when you look up in the sky, and we don't see them a lot now because it's kind of weird times and the planes aren't flying as much. But if you see that contrail, that white streak way up in the sky from a jet plane, okay, that's like 5 miles up there. Okay, that's how far Mount St. Helens was blowing. Just the ash and the steam and everything was rising up that high. So volcanoes are not something to mess around with. Okay, now there's some good news. Okay, unlike an earthquake, which we're trying to figure out some prediction methods, and we're getting pretty good with some of the technology. We can start to see, like on the San Andreas Fault, pressure's building, and we can say that, you know what, there's a lot of pressure and time has gone by and we haven't had a really good earthquake on the San Andreas Fault. So I think maybe in the next year or two, we'll have one. So that's how scientists predict earthquakes. Volcanoes, though, we'll see the dome building. You'll see plants start dying around it because the oxygen starts getting disrupted because sulfur gases start coming up from all this, this melted earth underneath. It start changing the ground around it. So all the plants and the trees and the grasses die. So they have all kinds of instruments. They'll go and stick probes in the side of these, mounds. And, they'll start getting a bunch of little trimmers, and, they're really sensitive to measure the gases that are out there and even the temperatures. And sometimes they can even go deep enough and get right there on where the magma is underground, and they can start sensing, sudden temperature spikes, and they're going to go, you know what, this volcano is probably going to blow up here in the next week. That's a pretty darn good prediction when we're talking about Mother Nature up here, our big blue planet. I mean, no one can predict anything with any surety when it comes to Mother Nature. Okay, we can see clouds in the sky and go, looks like rain. But is it going to rain? It may not. But the only thing that's for sure is the sun rises because the earth spins around, and the sun sets, and the moon rises, and the moon will set. And that's because the moon goes around the earth. Okay, so we can go up and go, the sun's shining. Now, is the sun warm? Well, yeah, right now it is. But no, not really. For us down here on Earth. Okay, so right now, this is Africa. Australia would be right there's the very tip of Australia. Right now on the southern hemisphere of Earth, because it's now May, almost June, it's getting to be winter down here. So their sun that they see is actually colder than the sun that we're seeing up here, in North America, where it's getting, kind of warm right now. Okay, so some little things. Okay, so what else about a volcano? Okay, it's spitting fire. Okay, anything that spits fire, okay, I'm tagging out. I'm done. Okay. Deep under the earth, rocks melt into a thick liquid called magma. When the pressure in the earth's crust builds up, the magma explodes in a volcanic eruption. Okay, so see, this is what I was talking about here. Heat and fire. The red molten rock that explodes out of a volcano is a beautiful but deadly. It is so hot that it can melt steel. Oh, that's it. Okay, I'm done. Okay, so what else do we... Oh, here's a temperature here. Little fact. Deep in the earth, below the mantle... Okay, so... this is our mantle here. This layer is made up of iron and nickel that has melted. Below the inner core, where the temperature reaches... Are you ready for this? 8,130 degrees. Okay, so they're talking about this inner core. Okay, so let me draw you something real quick. So the Earth has layers, okay, the crust. And I'm going to be honest, can't remember them all, but, you guys are little, you'll get this. Okay, so we have our Earth, okay, big round blue planet. Okay, and then I can't really draw the crust, so we're just going to say my circle is the crust. And then underneath that, we have another layer. Okay, so if we're talking about oil, we're usually digging down through the crust, and then we're down in here. And then we have another layer. Okay, and then in the very center, okay, we have this solid core. Okay, so this is liquid. It's solid, but it's a solid molten liquid. And then through here, we have varying degrees of moltingness. Okay, so melted earth. Okay, and then we have maybe an earthquake. A volcano over here, and then maybe a volcano down here. So what happens is, this is the molten stuff. Let's see if I can get another color and just use black. Okay, we get a little rip. Okay, like I said, the earth shifts. We have earthquakes, right? And it starts coming up. And eventually, it makes that mound and it explodes. Kind of crude, but I think you get it. You're young. You're going to get a whole bunch of this. It's called earth science. So let's see, what else? Okay, so look, see, here is the jigsaw of Earth. So we have these zones all over the Earth. The Earth is made up of plates. Okay, so imagine like these two books are plates. Okay, so let's look at this. We live in the Pacific plate. Okay, so we're about, you know, there somewhere. Okay, because here's the San Andreas Fault, and then this would be, you know, Lassen and Mount St. Helens and some other one up here. And then out here we have Hawaii. Okay, and then I think right about there's New Zealand. And then over here's Japan. Okay, so if we look on the other side of our book, okay, so this circle connects to this circle over here. It's really hard to look at Earth on a flat scale. You gotta trust me here. Okay, so here's Australia. So this is all one plate. And you see Australia, it's like on another plate. So what happens, you know, we have these plates, which, you know, they're like rips in the Earth, deep, deep, deep down. Like here, you know, it's going to be in the ocean. So these plates are what always are moving around, okay? You know, some are going apart, some are drifting together. You know, our Earth is always moving. We just don't always feel it, okay? So we have like this jigsaw of Earth, the crust that is broken up into pieces called the plates. Sometimes we can feel them move, which is an earthquake. Okay, now on the plates' edges, if you look at these, see, look on the edges of these plates. This is South America. There's a Pacific ring. This is Alaska and the Bering Strait, and then coming over into Russia and China. Sorry, Japan. Look where the volcanoes are. Okay, so remember I said that the volcanoes, they look for that weak spot in the Earth to come up. Okay, well these plates are the weak spot. So that's where we find most of our earthquakes. Okay, and see like here you can put, this says all in a row. On Lanzarite Canary Islands, magma bubbles up in places where plates break apart. These weak spots are called fissures. Okay, and then right here, this is the San Andreas Fault in California, where the two plates slide against each other. The plates move about 1/2 inch each year. Okay, now that's just like normal movement, no earthquakes. They're just kind of like, because remember I said the middle part of Earth here? See this huge liquid thing? Okay, the plates are floating on it. So just, you know, no earthquake, nothing else. Okay, the little plates would kind of move apart. But now if there's an earthquake, like there was in Tonopah, I saw a guy standing in the fault area. Okay. So the fault is where, here, this was Earth, okay? Down there by Tonopah, 2 weeks ago, nice and flat. It dropped off like that, okay? All this dropped off, and this was the bottom side, okay? And I had a friend that was standing. I'm kind of crude with my pictures. He was standing like that on the ground. His feet were here now because there is about a 2.5 foot drop in the Earth. I didn't feel that earthquake. People around here said they felt it, but I did not. Okay, so what else about volcanoes? Okay, maybe just a little bit more. An island of fire. Reunion Island in the Indian Ocean contains one of the world's most active volcanoes. Okay, I'm going to try to pronounce some of this. Okay, Piton de la Florenaz. Reunion Island formed a hotspot over 5 million years ago. That's a long time. And then, you know, my family and I, we went up to Yellowstone a couple years ago. It's up in Wyoming and Montana. Yellowstone Park in Wyoming is located over a hotspot. 2 million years ago, a volcano erupted here. Today, volcano heats fuels the park's 10,000 geysers. So, like at Yellowstone, they have this one geyser, it's called Old Faithful. And you know why it's called Old Faithful? It's because just about every 90 minutes, you know, almost set your clock by it. Sometimes it's like 87 minutes, sometimes it's like 92 minutes, but you know, basically 90 minutes, okay? It makes a huge geyser of water that spits up about 150, 180 feet out of the water. It's pretty amazing. Sorry, out of the ground. Okay, so what else do we have? Rivers. Oh, we were talking about Hawaii. So when volcanoes erupt, hot liquid either explodes outward or flows onto the ground. Okay, here it's flowing. Once it's outside of the volcano, the liquid rock can damage a lot. Okay, so remember, I mean, this melts steel. This is melted earth. I mean, you gotta heat a whole bunch. You gotta put a lot of heat to melt the earth. Okay, so in Hawaii, and this is probably a picture of Hawaii here. Every now and then the volcano, you know, because it kind of follows, you know, the slope of the ground. It's like water, you know, it's going to find, you know, the path of least resistance. And sometimes it gets a little hotter and spews out a little bit more. And so in this case, you know, it crossed over the highway. And in this particular one, I remember it got down into a housing area and it burned, you know, like 100 houses. And there's nothing, absolutely nothing you can do. I mean, it's lava. I mean, you can put water on it. You could have the firemen stand here and throw water on it. Yeah, it's going to sit there and laugh at you. Okay, so lava is nothing to mess around with. Okay, let's read some lava facts. The temperature of some lava is 7 to 12 times hotter than boiling water. Okay, well, we already know boiling water is pretty hot. That's like 200 degrees. Actually, 212. The word "ah" and "pahoa" come from the Hawaiian language. Lava can form many different shapes, such as cones, tubes, and even hair. And here's like a flowing river of lava. And when it cools, it'll make a hard skin. And the lava, oftentimes for, you know, it could be 100 years, the lava will slowly creep under that hard skin. So if we see here, you see it's cooling off, it's kind of forming a skin. And you can see underneath here, this is already kind of like cooled off, but the lava is still creeping under there. And see, under here, all this is a hard, crusty skin. Now, there are places where it's pretty thick, and in Hawaii, there's actually tours. You can go out and walk on this stuff because they've figured out, they test it, you know, they can shoot thermal imaging, and they can see the lava's like, I don't know, 3 feet below this crust. So it's relatively safe if you wanted to take the risk to walk out and get within 100 feet of this stuff. I think I'll pass. Okay. Okay, so this is one that's blowing up. So when I was talking about Mount St. Helens, it just blew up all this gas and ash and gravel and clouds. It's just a huge hot cloud. Okay. So I think, you know, this book has some other stuff. Yeah, see, then you get volcanic weather. Okay, so this is kind of just getting a little different, into stuff. Then we get tsunamis. Okay, so, you know, there we go. Oh, here's Old Faithful right here, up in Wyoming. So see, it's just a geyser. Okay, so about every 90 minutes, it shoots water, steaming water up 100 to 165 feet in the air. I'm sorry, it's 78 minutes. I said about 90. I was close. Okay, so, and there's some really pretty geysers up in North Reno. If you wanted to go see something that looks almost exactly like this, it's called Fly Geyser. Makes for a really nice day trip. Okay, so I think that's about it on volcanoes. You know, I really didn't have a book to read per se, but hey, we learned something about volcanoes. We had our science lesson today. Yay! All right, time to go do something else. I need to go put another coat of paint on in my kitchen. Yay!